Well, a student had asked about this one, so I thought it would be good to do it. And what we end up seeing a lot of the times is students are just taking these two terms on the inside and squaring that. You can't do that because, remember, it's not just that you're squaring those two terms, you're actually squaring the two terms together. So here's what I mean by that, is we're going to take the binomial, which is 3 times the square root of 5 minus 4 times the square root of 2. That is what is being squared. So we're going to take it and just simply multiply it by itself like this. From here we can use distribution. So first up, in the blue distribution would have 3 square root of 5 times 3 square root of 5, which is going to be 9 times the square root of 5 times 5, which is 25. That is a perfect square, so we end up with 9 times the square root of 25 is 5. 9 times 5 is 45. And that simplifies at least that much. Next, we're going to distribute the 3 times the square root of 5 and multiply it by, it's really negative 4 times the square root of 2, because remember, it's a minus sign right there. And then we'll multiply the 3 and negative 4, which is negative 12, and the 5 and 2 in the square roots, which is going to be 10. So it's negative 12 times the square root of 10. This one, it does not look like it can be simplified, and you could put that in the calculator just to check. So I'm just going to bring it down into my final answer. Next distribution would be negative 4 times the square root of 2 times 3 times the square root of 5. Well, we've already done that, and you can see right here it's just a different order, but it really is the the commutative property of multiplication. And we can see that negative 4 times 3 is going to be negative 12. We see the match. And then the square root of 2 times 5 will be 10. So it's really the square root of 10. I'll keep that as a different color to show it came from a different distribution. But then our final distribution here would be the negative 4 times the square root of 2 times the negative 4 times the square root of 2. So we're simply going to take that and multiply it by itself with, again, its multiplication. And so we got the negative 4 times negative 4. That's going to be positive 16. And then we got the square root of 2 times 2 is 4. 4 is a perfect square, so it's going to end up being positive 16. The square root of 4 is 2, and 16 times 2 is 32. So from here, the last thing we would need to do, that you should always do, is to see if there's any like terms you can combine. There are, right here in the middle, we've got 2 square root of 10 terms, and it would be a negative 12 minus 12 there, which is negative 24. So our final answer, we still got that 45 in the front. Oh, well, I need to combine that, don't I? So let's go ahead and do that then. Let's see if we can find a decent color to choose from. I don't know. This one seems like it's okay. So we got 45 and 32, which we are going to combine. So again, we would write this in as 45 plus 32. Again, you can just put that in the calculator, but you should get 77 on that one. And now, this one's complete. I almost forgot to combine my like terms, but we caught it, and we fixed it, and this should be our final answer simplified. Now, if you had written it as negative 24 square root of 10 plus 77, you're going to get the same answer because of the commutative property of addition, but I'm just going to keep it this way because it looks good to me.